Let's have our lecture video in integral calculus with the topic integration of rational fractions. The third one, quadratic factors. When the integrand involves denominator of the form ax squared plus bx plus c with b squared minus 4ac less than 0, then assume a partial fraction as a times 2ax plus b all over ax squared plus bx plus c, where the big letters a and b are constants to be determined. Now let's exercise this by answering the following examples 1 and 2. For number 1, we have here the integral of x dx over x squared plus 6x plus 13. Now we need to determine first if we will apply here quadratic factors. So knowing this as a, small b, and small c, let's check. So b squared minus 4ac, is this less than 0? So we have b as 6 squared minus 4 times a, which is 1, and c as 13. Is this less than 0? So c squared is 36 minus, that is equal to negative 16 less than 0, correct. So therefore, we will use quadratic, meaning it will not have a factor. So we cannot use linear or we cannot use repeated here. But we will go to the last resort, which is the quadratic factor. We write here as x over x squared plus 6x plus 13. For the partial fraction here, we will use the form given here, which is a times 2ax plus b over x squared plus 6x plus 13. So our a here is 1. So we have here a times 2ax. A is 1, so we have here 2x plus b. Our b here is 6 plus b over x squared plus 6x plus 13. Then we will now multiply both sides with the denominator x squared plus 6x plus 13, meaning these denominators will cancel out. So what's left is x is equal to a 2x plus 6 plus b. So x is equal to 2ax plus 6a plus b. Equate x. So we have here the x as 1 equals to a. Therefore, a is equal to 1/2. Now for constant, equate constants. So we have no constant on the left side, equals 6a plus b. Now b is equal to negative 6a, which is 1/2. So b is equal to negative 3. So having the values for a and b, let's now proceed to rewriting again. So integral of x dx all over x squared plus 6x plus 13 is equal to integral of the value of a as 1/2 times 2x plus 6 plus, that's minus 3. So we're doing this one, writing this one, all over x squared plus 6x plus 13. So this is dx. Okay, so let's simplify further. So if we multiply this here, what happens is we have here as x plus 3 minus 3 all over x squared plus 6x plus 13 dx. Separate them. So integral of x plus 3 dx all over x squared plus 6x plus 13 minus 3 dx x squared plus 6x plus 13. This will still go back to the original equation. Okay, then let's integrate them separately. So this one here, we can have this as logarithmic. Then let's see if we can do something about this, because if we let here as x squared, we can use here completing this square. Okay, x squared plus 6x plus, what is 6 divided by 2? 6 divided by 2 is 3. 3 squared is 9. So what is 13 minus 9? That is 4. That's 4. So that this will still go back to this form here. Therefore, we have here x plus 3 squared plus 2 squared. Looking at this will remind us of inverse functions. So solving inverse functions is discussed in the previous videos. Okay, we write again. We have here x. So let's have this also. If this is u is equal to x squared plus 6x plus 13, then du is equal to 2x plus 6 dx, or du is equal to 2 times x plus 3 dx. Okay, right? So we have here 2x plus 3 dx. Compensate by having 1/2 here, all over x squared plus 6x plus 13 minus 3 integral of dx all over x plus 3 squared plus 2 squared. Having u here as x plus 3, du is equal to dx. Then we have here a is equal to 2. Okay. Therefore, the final answer here is equal to 1/2 ln of x squared plus 6x plus 13 minus 3 times 1 over a for arctan. So 1 over a here is 2 arctan u over a plus c. Simplify further, we have 1/2 ln of x squared plus 6x plus 13 minus 3 over 2 arctan of x plus 3 all over 2 plus c. That's the answer for number 1. Okay, screenshot first before we proceed. Okay, so let's have number 2. We have here integral of 9y plus 14 dy all over y minus 2 times y squared plus 4. So we can have the linear factor here, but first we will test, since we are seeing here a quadratic equation, we will test if we will use the method C, quadratic factors. So let's test it first. B squared minus 4ac. Is it less than 0 for this one here? This is A. And then this is constant C. So we have B as 0 minus 4AC. Is it less than 0? This is negative 16. And yes, it is less than 0. Therefore, we will use the third method, the quadratic factors. We write. So we write here, we have 9y plus 14 all over y minus 2 y squared plus 4 is equal to the linear first, a, distinct linear factors, a over y minus 2 plus the quadratic one, b times 2ay, so in this case it's 2ay, so here it's 2ax, but here we will use 2ay, a being 1, so we have 2y, plus b, we don't have b here, so that is 0, plus c, and over y squared plus 4. So we have here the denominator that is in quadratic. Then multiply both sides with the original denominator, y minus 2, y squared plus 4. Multiplying this on the left side of the equation, we will cancel this one out. So what's left will be 9y plus 14 equals a times y squared plus 4 plus, now for b, we will cancel out this one here and then distribute y minus 2. So b, 2by times y minus 2 plus c times y minus 2. Okay, distribute again. 9y plus 14 equals a y squared plus 14a. Oops, so my it's not 14, it's 4 4a plus 2b y squared minus 4by plus cy minus 2c. Okay, so we cannot simplify this anymore. Let's concentrate here. Equate y squared. So we have here 0 equals a plus 2b. This is equation 1. Equate y here. So we have here 9 equals negative 4b plus c. This is equation number 2. Equate constants. We have here 14 equals 4a minus 2c. This is equation number 3. Then, if we want to remove c, so we will concentrate with 2 and 3. So at equations 2 and 3, we have there 9 minus 4b plus c, and 9 equals, 9 equals, since we have here 4a, so let's arrange it properly. So we have here negative 4b plus c. Then for equation 3, we have 14 equals 4a minus 2c. To eliminate c, we will multiply 2 with equation 2 with 2. So that is 18 equals negative 8b plus 2c. This is 14 equals 4a minus 2c. Cancel out 2c. So what's left is 32 equals 4a minus 8b. And that is equation number 4. Now to eliminate b, we will concentrate with 1 and 4. Okay? So at equation 1 and 4, we have 0 equals a plus 2b, and then 32 equals 4a minus 8b. Multiply equation 1 with 4. So we have here 0 equals 4a plus 8b, then 32 equals 4a minus 8b. Cancel out b. So what's left is 32 equals 8a. So we now have the value for a as 4. Now to get the value for b, we substitute a to 1. That is 0 equals a, which is 4, plus 2b. So we have here b is equal to negative 2. Having the values for a and b, substitute to get the value for c. So we have here substitute a and b to, we can just use b. So substitute b to equation 2. You can use equation 2 here. So 9 equals negative 4b, b being negative 2, plus c. So 9 is equal to 8 plus c. C is equal to positive 1. So having the values for a, b, and c, we can now rewrite. Go back to the this part here, the equation. So we have integral of 9y plus 14 dy all over y minus 2 y squared plus 4, that is equal to, value for a is 4, integral of dy over y minus 2. Then if we separate already the b and c, so we have there b 2y over y squared plus 4, and then we have c over y squared plus 4. Okay. Or so that we will not forget, okay, so let's put it here. 2y plus c all over y squared plus 4 dy, 4 integral of dy y minus 2 minus, this is 2y dy So we will understand why I left 2 there. Then we have here minus okay, so if we look at this, we will have here plus. Yeah, because this is plus and this is just the minus 2, right? Yes, it is that way, okay? Then we have plus integral of dy all over y squared plus 4. Then u here is y squared plus 4 du is equal to 2y dy. So that's the reason why I left this as it is. Then u here is y and a is equal to 2 because we will be using here arctan. Okay. Therefore, this is now equal to 4 ln of y minus 2 minus 2 ln of y squared plus 4 plus 1 over a arctan u over a plus c. So this is now the answer for number 2. So this is the screenshot first. Now, as an added for this lecture, you might want to use your calculator to check if the constants that we have computed is correct. So, looking at this, we have the 3 equations as 0 is equal to a plus 2b, 9 equals negative 4b plus c. Then we have 14 equals 4a minus 2c. And these are the constants a, b, and c. You can use your calculator. So right now, I'm currently using here Casio f of x 991 ES plus. This is for checking only if the constants that you were able to obtain were correct. Again, let's rewrite the equations, but let's arrange them. A, so the constants, what I'm going to get here is the equations, and I will put the constant on the right side. So A plus 2b equals 0. This is the equation 1. Then we have here negative 4b plus c equals 9 for the equation 2. We have 4a minus 2c equals 14 for the equation number 3. Now, using your calculator, push the button mode, choose the number 5, which is the equation. Then, go to the equations with 3 unknowns. So, we have there number 2, which is a n x plus b n y plus c n z equals d n. So this is the reason why I arranged this arrange it this way because that's what the arrangement needed in the calculator. And take note that x here is your A, y is your B, and then z is your C. Whatever the value that comes out in the calculator as the value of x will become the value for A. So you will click enter, and then we will have this form here as tabulation. So that's too wide. We have 4 columns, A, B, C, and D. Then we have 1, 2, and 3 rows. So remember the equation 1 here. The equation 1, for A, we have there 1, 2 for the B, and then you don't have any C. And then for D, you have the value of 0. For A here, there's no A for the second equation. Then you have here negative 4B plus C, and then we have here 9. Then we have here 4. Then we have 0 for B, and then negative 2C. Then we have here 14. Now every input of the number, you press equal sign, the equals. So let's do it in here. Oops. Okay. I don't know how to. Okay. Oh, that's hard. So I click their mode. Then I choose the one with the 3 equations at 3 unknowns, should I say 3 unknowns. So here you go, that's the table. So I will input there 1. So I already have tried it here. So 1 equals input 2, then equals input 0, input 0, input 0, input negative 4, then input 1, input 9, and then click equal, input 4 equal, 0 equal, negative 2 equals, 14 equals, and then click equals again. Then you can see the value for x is equal to 4 equals y, the value of negative 2, click equals again, z is 1. Then you remember that for x that is also A, y is B, and then z is C. Now to go back to your normal function of your calculator, click mode, and then computer. So in your calculator, click mode, and then number 1, computer, so that it will go back to the default function of your calculator. So did we get this right? 4 negative 2 1. Yes, it's 4 negative 2 1. So you can use this as for checking only. The calculator that I have here, the Casio f of x 991 ES Plus, only have 3 unknowns. So if you want to, if you have equations with 4 unknowns, you can reduce it into 3 and then use this to solve, or you can use whatever means to check if this is correct. Okay, so that's it for this video.